Hello, my name is Arun Dutia. I'm on the PSP Liquid Propulsion Rockets team, and today I'm giving you a basic rundown on how to do Ansys, specifically for impeller blades. So first, we're going to come over to the bottom right. You should have installed Ansys and CFturbo by now, and we're going to drag in that CFturbo extension. And now we're going to double-click Setup, and what that's going to do is that's going to open up CFturbo. So if we wait over here, essentially what this is going to do is it's going to allow us to import our project into Ansys. So right now I've already created an existing CFturbo file called high wrap angle test, and generally you want to create that file in CFturbo separately and not in Ansys. And right here it'll open up to our project. So the first thing we're going to do is we're actually going to head over to the impeller portion of the section right here, and we're going to click on CFD setup. And what we need to do is we need to enable the extension here, and we need to select extension outlet at R equals constant. And then what we're going to do is we're going to head over into project and Ansys workbench. This is where we define our parameters in order of the parameters that we will be bringing into Ansys. So we're going to go into export actions, and we need to select at first our impeller. And with that, we want to use Ansys Turbo Grid, and we need to select flow domain virtual, and we're going to add that in. And now what we're going to do is we're going to go to Ansys space claim, and we're going to select both our stator and our volute. Make sure again to select flow domain virtual, and we're going to import both of those into space claim as well. And now we're just going to close it over here. Okay, up next, what we're going to do is now we can close a CFturbo and we're going to save it. And what this is going to do is it's going to bring all of that data into Ansys for us to use for our analysis. The first thing we're going to do is we're going to click Turbo Grid. We're going to right click, we're going to hit Transfer Data to New, Turbo Grid. And then we're going to click on Turbo Mesh, hit Update Upstream Components. I'm going to let that do its thing for a sec here. And then now everything's updated. So now we're going to do this. What we're going to do here is we're going to hit Transfer Data to New, Mesh. And once again, we're going to need to update our geometry. This essentially just pulls all the data and makes sure everything's up to date so that each of these individual subsections can also read the data that we are importing from CFturbo. For our third one, again, what we're going to do is we're going to hit volute, transfer data to new, mesh. And once again, we're going to need to update our components. All right, there we go. Now everything should be updated. So now what we're going to do is we're going to go into Turbo Mesh, and we're going to double click Turbo Mesh. And what's going to happen is it's going to open Turbo Mesh into a new window. So if we give it a minute here. Again, a lot of these stuff, Ansys is not the most optimized, and also it's just a lot of computations for it to go through, so it does take a minute for it to open up. And there we go. And we're going to let it load here. Going to create our impeller. So this is a single blade of our impeller. We're going to go down to the topology set, and we're going to unsuspend those object updates. I'm gonna let that load up real quick. All right, so we're gonna get this warning, and we can just ignore it. It's not really a big deal. I don't know why that warning exists, but you can just safely ignore that. And then just like that, we are able to close it. One quick note is sometimes for more higher detailed blades or splitter blades, we may need to downsample it, but in this case, we don't really need to worry about that. So now what we're gonna do is we're gonna open the mesh program for our second one. Gonna let that load. All right, here we go. So everything is gonna slowly pull in. And what we basically need to do is we need to take our imported stator and volutes, and we need to convert them into meshes, which Ansys can then use to utilize. So what we're going to do is we're going to go over to mesh, we're going to right click, and we're going to hit generate mesh. There are more advanced settings to adjust the mesh quality, but for something like this, generally we can just leave it as kind of lower quality. Anyway, the education license limits us to 1 million nodes, so we don't want to exceed that. And again, we're going to go here, and once again, we're going to double click the mesh program and let that load. And here we go. This is our volute section. So we're once again going to create a mesh for this one. Here, we're going to hit generate mesh. Again, the mesh looks kind of low quality, but that's okay. We can close out of that one as well. And now what we're going to do is we're going to click on our turbo mesh, right click, transfer data to new, CFX. And now what we're going to do is we're going to drag both our meshes into the setup section. Basically, we're uniting everything into one big impeller model. So here we go. Now we're going to hit update upstream components. Basically, that just updates everything, make sure everything is updated, and then pull in all those data, those mesh data for the stator and volute, as well as the turbo mesh data for the impeller itself. I'm going to let that load up here. Again, Ansys tends to run a little slow sometimes. So again, this takes a while, but there we go. So what you notice is that the impeller itself only has pulled up one blade, right? So we need to rotate that by going into TS, hit Mesh Transformation Editor. We want to be in rotation, and we want a rotation angle. For this case, it's a 60-degree angle because we have 6 blades, so 60 times 6 is 36. We're going to have 5 extra copies. That way we have 6 blades total. And then we're going to hit apply and close that out. And just like that, now we have all our blades circulating around. And now what we're going to do is we're going to Tools, Turbo Mode. This is where we can set up our impeller for the analysis part of it. So our machine type is a pump, and we're just going to skip through and hit the next section. Our component R1. So what we're going to do is we're going to click on that. And this is the rotating part of our component. So for our analyses, we have negative 3,000 revolution, 30,000 revolutions per minute. That's defined by the parameters of whatever you're analyzing. And then now what we're going to do is we're going to select the blade volumes, the part that's actually rotating in our impeller. So what we're going to do here is we're going to delete only B36 and B48. Those are the models that are the volute and the stator. Now, it kind of depends on what your model is doing, but you can kind of double check by what's selected here. As you can see, only the blade volumes are selected here. What we're going to do now is we're going to add a new component. And this one needs to be static. We're going to be adding our volutes and our stators in. So we're going to name this one S1, just for stator 1. We're going to hit OK. And now what we're going to do is, since it is already selected as a stationary type, we're going to select the stator model. We give that a minute to load. So in our case, the stator model is the B36 model. You notice that it highlights the stator part of our impeller. And then what we need to do is we actually need to add region information. So for our blades, the region information was already filled up. However, in these ones, since it didn't recognize it initially, we need to actually select all of our region information. So for our hub is essentially the inner part of our circle, and then our shroud will be the outer parts of our circle, of our stator, I guess. Then we also need to select our inlet, which is the top portion of our stator. And then finally, we'll need to select the outlet, which will define the bottom port of our stator. All these individual components basically allows Ansys to determine where the flow is coming in, where it's going out of, and how it's going to actually interact with the volute itself. So over here, I just selected the outlet. And then what we're going to do is we're going to add one more stationary component. This is going to be our volute section. So again, volute, and we're just going to name this one V1 or volute 1. And we'll hit OK. Now, remember, there's one more section left, and what we're going to do is we're going to select that volute section. And for the volute section, we actually don't need to hit about the hub. We don't need to worry about the hub and the shroud part. We just need to worry about inlet and outlet. So the inlet, it's a little hard to see over here, but the inlet part of it is essentially that really narrow section around the blades, essentially where you expect the high, now accelerated fluid to hit, and that, or like to cross into in order to hit our volute. And then our outlet part is the outlet valve of it. And here's the outlet part. So this is what we're going to select. There we go. And now we have our entire impeller selected. And so now what we're going to do is we're going to hit next. And now what we're going to do is we need to reorder our components in the order in which the fluid hits. So obviously the fluid enters through the stator. So the stator is the one that'll go on top. Then it'll hit our rotating part, our blades, and then it finally exits through our volute. That's why we have S1, R1, and then V1. Now, again, for selecting our fuels, in this case, we use ethanol. So we're going to go into our data here. We're going to hit positive property liquids, hit ethanol. We're going to OK that. That imports it into our Ansys and allows us to select it. Reference pressure, I tend to set it to 0. It gives us like when our reports are generated, it gives us better reports. Heat transfer, none. Turbulence should be shear stress transport. We need to select P total inlet mass flow outlet for our analysis. Kind of varies on what team you are on. In this case, we know our inflow pressure, which is 80 psi. And then we also know for our outflow, our mass flow rate for the exit, which would be 2.93 pounds per second. And we actually need to select per machine for our mass flow if you notice that. And we don't need to worry about solver parameters or anything. And we're going to hit next here. Now we see these, it's a warning. Basically, it's asking if we want to generate the passages through each one, and we're going to hit yes. And now we have our interfaces. So that's all set up, and we're going to hit next again. Next again. And now that we're done, we're going to hit finish. Now you notice we have a warning in the console. We can ignore that. Ansys is strange sometimes. And this one is a little interesting. This is expert parameters. So what we're going to do here is we're going to go to convergence control, and we're going to change our topology factor ZIF to, I change it to 1.5. If your PC is a lower end computer, I have 32 gigabytes of RAM, but if your computer is of a lower end, don't touch that. It just allows Ansys to use more of your RAM. So now we're going to close out. All right, so now our setup is successful, as showed by the check mark. So now we get to click Ansys Solutions. And what's going to happen is this is the main bread and butter of Ansys. This is where it'll attempt to simulate flows, and this is how we're able to generate our data. And so while that's loading up, I'm actually going to pull up Task Manager here to make sure, essentially, Ansys doesn't like overtake my memory, doesn't cause any issues. I'm just going to keep it here. I'm going to actually terminate Firefox here to save some memory, just to make sure Ansys doesn't cause my computer to crash, because there are some weird bugs where if Ansys crashes, it doesn't recognize your license. What we're going to hit here is we're going to hit Start Run. And just like that, we now have Ansys running. So now that our report is finished, we're just going to hit OK, and then we get to close out of CFX real quick. And now what's going to happen is we're going to go hit our results section. Let that load up real quick. All right, so now we get a really blank version of our impeller, and obviously we want to see our streamlines. So we're going to do is we're going to go up top, we're going to show that airfoil thing, and we're going to hit Insert Streamline. And we want a 3D streamline, and we want our streamline to be of our S1 inlet as our start from, and we want equally spaced. And the number of points essentially defines how many streamlines you are actually generating for you to see. The more streamlines, the longer it'll take to generate it. So I just set mine to 250 over there. And there you go. And we have a really nice impeller here. Now, when you're doing impeller analysis, there's a couple things you want to look for. First off, you notice that there are nice straight lines around here. However, there's some wiggly room that's turbulent flow. And generally for impellers, we're trying to minimize turbulent flow. So usually you want those streamlines to be nice and straight. So obviously this impeller isn't fully optimized. So we're gonna hit File. We're going to hit Report, Report Templates. And this basically gives us our reports. We're gonna scroll down here to Pump Report. We hit Load. And this report is going to give us all the data we need, the data we want to analyze, such as impeller efficiency, among other things. You can see it does some interesting colorful stuff. This is just pressure gradients. And oh, we got an error. So we got cannot initialize component 2, and the hub region is not defined. So that's okay. What we need to do now is, this is a pretty common error. We just need to go into our turbo. Now we want to select our components. We notice that they're red, right? That's because what's actually happening is our components weren't successfully selected. So right here, we're going to actually have to modify it by double-clicking component 2. We're going to scroll up all the way to the top. And we want our hub to obviously be our R1 hub. And then we're going to hit OK. And then we obviously want our shroud to be the shroud of our impeller. So R1 shroud. And our blades. But generally, we also want to just select our blades. These are the blades that we did analyses on. So we want to keep it nice and consistent. For our inlet, we just want to select R1 side 1. That defines our inlet valve. And then we want to hit V1 to R1 side 2. And that is our outlet. And then we need to hit 3D case without periodics and hit initialize. And this is going to load up real quick. Basically, this has now fully defined our impeller. So this time we shouldn't get any errors generating our report. All right, and now after everything's loaded, we can ignore our component 3. And now we can go into File and Report. Now we're going to go to Report Templates, back down to our pump report. And we're going to hit Load. And now, once again, we're going to get our nice colorful pressure gradients and lines. Load up our report. And now that it appears to be done generating the report, we can go down to Report Viewer. It's going to load up real quick. Okay, so now our report is fully loaded up. And I'm just going to show you some kind of key figures we want to look for within our report itself. So we're going to scroll down. And this is kind of our overall performance. Some component summary data, mean line charts. These are the fancy graphs that you could saw being generated. We're just going to scroll down here. Some more charts that you can look at. This is just kind of giving you references for what you kind of should expect to look at. That way you know your analysis was done properly. And then let's see. All right, so generally this is the most important part of our reports. Specifically, we want to scroll up here a little bit more. And we notice our total to total efficiency percent and our total to static efficiency percent as well. And generally, we are trying to aim for high efficiencies here. Unfortunately, Ansys and CFturbo is wonky, and we'll occasionally get an efficiency above 100%. No, that does not mean your impeller is generating energy. Okay, so this was a general overview of Ansys and how to be more familiar with the systems. There are obviously more settings you can play around with, such as ones where you need to do analysis on splitter blades, but this should give you a quick rundown of how to get yourself started, and you can look more into things as you develop your skills. Thank you for watching.